Hello, guys. Welcome to. I always, always yelling. I don't know why. Sorry, guys. Don't mean to yell at you. I'm just trying to, once again, create a little excitement. Hopefully, you can see me okay. I know my computer laptop camera is horrid, but you know what? We're not going to worry about that. I'm a small little person in the bottom right corner, so you don't have to pay attention to me, and you shouldn't be paying attention to me. You should be watching the slides, right? Today we're jumping on to 3.1. Now I know you're thinking, well, what happened to Unit 2? Well, those will come into play later, and I'm just going to kind of leave it at that without too much information. To hurry up with time, I'm going to just kind of get started into this one. But we're talking about ecosystems and biology, and this is the very biology-rich kind of unit. For those of you who might have missed biology or thinking about getting into one of these fields, this one's going to have a lot of those same concepts, and it goes along with environmental science, just geared towards saving the planet, right? But we're really going to get off starting talking about biomes and the different kind of environments that organisms live in. And it's key to understanding these before you can start understanding the complexity of different living environments and how special each of them are. And kind of talking about how these, we'll be talking about food chains, food niches. We'll be talking about these things that, if you start taking away an animal here and there, these things start to collapse. Thinking back to systems, right? There's a system, many pieces together equal this larger thing, and animals are the exact same way. So let's get to it. Biomes. I'm going to fly through this one. We're really going to talk about the major biomes that we'll discuss in this unit, or in regards to these different ecosystems. Just know that biomes are areas sharing similar climate, topography, and soil conditions, and thus the same basic type of biological communities. They're just areas that are kind of classified together, right? Like you have a tropical rainforest biome, a desert biome, tundra biome. So do know, they meet certain characteristics that put them into those categories. The two big things, what dictates what type of biome you have? This is key. Please remember this. Temperature and precipitation are the most, I would say, it says among the most, but are the most important determinants in biome distribution. Temperature and precipitation will change soil. It'll change the type of weather, climate you have. It changes all the type of animals and organisms in a given biome. So do know that it really has changed on temperature and amount of precipitation. And we'll kind of talk about this. This is just kind of a map. As you can see at the bottom, there are many different types of biomes. And this isn't even the start. I took a biology course in university to get my science degree, right? And there are so many more categorized. There's so many more sub biomes that are out there. But just know, for environmental science, we're going to talk about the main big ones. I forget how many there are, 7 or 8 here. We'll talk about those main big ones, and we'll kind of, we kind of leave out the other one. But just know that there are many more biomes, and it's key to understand, and I think I will talk on this later, but a biome, it doesn't go from tropical rainforest, we're looking at this map, right? Dark green is tropical rainforest. It's not like as soon as you go into the color, it stops being that. That's not how the real world works. Obviously, there's a lot of area between that kind of gradually changes from one to the next. So, and then sometimes those areas are given certain names. So do know that there's many different types of biomes out there, but we're going to talk about the main big ones. And do know they don't abruptly stop, right? They don't, rainforest doesn't stop, then desert begins. It's not like that in the natural world. Okay, so the two things, like I said, what it really dictates a biome is the amount of precipitation and the amount of average temperature. Stop, pause this. Really look at what this graph is trying to tell you. It might pop up again somewhere, or at least it'll greatly help you out in the future of this unit and as actually quizzes and tests. So this is an important one, right? But the more, certain biomes fit in having within those two kind of categories, the X and Y axis. A tropical rainforest. we get annual precipitation is around 300 or more, right? 300 more, and the temperature usually is between 30 and 20 degrees Celsius. That, if you have those two kind of key factors, most of the time you will have this biome, tropical rainforest biome. If it goes below that, let's say you get a little less rain, 300 to 200, and then the same type of degrees, then you get a tropical seasonal forest, and so on, right? So do understand what this graph is trying to tell you, and kind of understand where each of these biomes fit in regards to their perspective, temperature, and precipitation. We'll kind of go through that in the later kind of slides to kind of tell you where they fit, but this is key. Understanding this graph really is kind of like a quick cheat for you. That's why I attached it. Stupid joke. All right, temperature. So biomes, temperature and precipitation also change with altitude. Just know, when we're talking about, tropical rainforests, they tend to be along the equatorial zone. Hopefully you understand. Hopefully you know that already. If you don't, maybe you're going to have a little issue with this. But most tropical rainforests are along the equator, right? The equatorial zone, as we say. That's where kind of Thailand is, right? That's why we have a lot of tropical rainforests. The Amazon. Why? Because it gets the most average sunlight, the most average temperatures. Thus, you get a lot of energy, which puts a lot of precipitation into the air, and it rains a lot. Those are why. When you get to kind of the Tropic of Cancer and Capricorn, that's where you see a lot more desert areas. Why? Because that's where there's a lot of high pressure. Hopefully some of you remember this from your earth science class. I know some of you took this course with me, so hopefully you kind of remember some of those aspects about why we have the desert regions near the those kind of zones, right? So it does go by latitude, right, on the earth. But do know this one kind of talks about vertical zonation, or a term applied to vegetation zones defined by altitude. It's like going up a mountain, right? At the bottom, this is giving an example of Mount Whitney. You might have a lot of the desert on the main level, right? But as you go up, you might get a little bit more precipitation because of elevation. It allows more precipitation to drop. So then it kind of changes into a grassland area, then oak woodland, oak forest, and then you might get all the way up to the top where it's polar and you have the kind of alpine or tundra because it's so cold at the very top. So do know it really dictates on latitude on the earth, but also altitude on the earth, and that's called vertical zonation. Key term there. All right, so the first one we're kind of getting into is rainforest. Hopefully you guys all know rainforest because we kind of live in a rainforest environment, or at least Thailand has part rainforest environment. These are humid tropical regions supported by one of the most complex and biologically rich biomes. Why is that? Hopefully, that's kind of a question. Why is ours the most biologically rich? Well, you get a lot of sun, you get a lot of rain. When you get a lot of those two things, you have an explosion of growth. There's more plant life that can grow because there's more sun, so more plants can grow. Then if you have more plants growing, well, you have more food for the secondary, the primary consumers, and then the secondary consumers. So do know that these areas tend to be much more diverse, and we'll kind of talk about them. But these are probably, when it comes to environmental science, rainforests, tropical rainforests are the most important because they just have so many more species than the other ones do. So I think I kind of talked about this, but they really have ample rainfall and uniform temperatures. They also have cloud forests can fit into this. High mountains where fog and mist keep vegetation continually wet. So cloud forests are kind of on the altitude. Tropical rainforests are more on the latitude. But cloud forests you have a zone on mountains sometimes that gets so much rain because the humidity goes up and then it gets cooled down and it drops all of its rain, so you can get these on mountains. And then tropical rainforests occur where rainfall exceeds 200 centimeters or 80 inches per year, and temperatures are warm to hot all year round, so kind of the 20 to 30 centimeter range, 20 to 30 Celsius range. Sorry about that. Continuing on rainforest. Soil, and this is key, we'll get to this in the agriculture unit, but soil and rainforests tend to be thin and nutrient poor. So I know what you're thinking. Well, why is the soil so bad if there's so many plant life? Well, that's partly the reason. first off, you have tons of plant life, which then take up all those nutrients into the soil. So then it leaves very little into the soil. But then when the plants die, normally it would leave in that soil. But what you have is so much rain, and the rain leaches or kind of pushes the water through the soil and washes it away. So there's just so much rain that it makes poor soil. That's why rainforests tend to kind of have bad soils. Thailand is not the best for growing tons of crops because of this reason. Now, us living in Bangkok near the Chao Phraya is a different situation. Why? Because you have all this rain up north. It pours all those beautiful nutrients through the Chao Phraya and kind of gives it to Bangkok. That's why Bangkok is here. We have good soil here, but most because of the river that flows through it. We'll get onto that more in the agricultural unit. But just know rainforests tend to have poor soil, and we'll discuss that in later units. 90% of the nutrients are tied up in living organisms, and then rapid decomposition and nutrient cycling, right? Things die very quick. When things die, they break down very, very quickly, so it kind of just gets washed away. Thin soil cannot support continued cropping and cannot resist erosion. Rapid deforestation occurring as people move into the forest. We're just really breaking it down. We're killing off those rainforests, and then the soil tends to be really bad. 1/2 to 2/3 of all species of terrestrial plants and animals live in tropical rainforests. We'll talk about this term, a hotspot. It's a hot zone for biological diversity. So kind of keep that in your mind. 1/2 to 2/3 of all species live in rainforests that exist on land. So do know that. We'll talk about slash and burn techniques later, and that kind of fits into this. Here's kind of a graph to kind of look at. This is just another graph like that earlier one, or that graphic I showed you earlier, but really says this is kind of what makes up a rainforest. It roughly stays very constant temperature all year round, and then rain, it gets just a high amount of rain all year round as well. So that dictates a tropical rainforest. Now, I have attached these videos up here, and as you'll see on Google Classroom, I've attached videos. They're just to give you an idea if you don't understand what these type of environments look like. So go ahead and watch those. I wouldn't say they're required. If you kind of know what a tropical rainforest is, you probably do, right? But some of the other ones you might want to look at. All right, continue along. Then we have the next one down, a temperate rainforest. These are dictated by more of a spike in. They have sometimes they can get their temperatures, and they still get a lot of precipitation, but they have a very wet year and a very dry period in their time period, kind of like Thailand. But the main difference in temperate rainforests is their temperature changes quite a bit too. In Thailand, we have a pretty stable temperature, so we're kind of in between a temperate and tropical rainforest. Temperate rainforests can get very cold, almost snowy at sometimes. In certain aspects, because look, as you can see, they get down to 0 degrees Celsius in many areas, so we obviously don't get down to that. Here's another video that you can watch for temperate rainforests. And that's just kind of I don't speak much on temperate rainforest because it's kind of a subcategory of tropical rainforest, if that makes sense. So we don't spend too much time on it, and I don't want to fill your head with stuff that you don't already need to know. And as you know, AP environmental science, there's so much you have to know, right? So it's kind of briefly touch on that one. Tropical savannas and grasslands are the next big one. Grasslands with sparse tree cover are called savannas. So think of kind of the plains of Africa, where you envision groups of lions, herds of elephant and wildebeest, right? This is kind of a tropical savanna or grassland. This would also be where I grew up in Nebraska, which is very farm community, very flat, not a whole lot of trees, just tall grasses as far as you can kind of look. So that's kind of fits into this group. Too little rainfall to support forests, but they get enough, right, to grow crops. Dry season is prone to fire, because it does have it doesn't get nearly as much rain, so you do often, and you have all those grasses because it's called grassland, so you do get fires often in these areas. Plants usually have deep, long-lived roots, and other adaptations to survive drought, heat, and fire. So plants are built for that. These grasses are usually built for that. They have these long root systems, you know, that if the top gets cut down, just like a grass at home, if you mow your lawn, it keeps growing, right? That's why we choose grass, not just because it's beautiful, but because it comes back time and time again. Many migratory grazers, such as antelope, wildebeest, or bison, live in these zones. And then here's kind of you can watch this video on tropical savannas and grasslands. I believe that would be the third one in this video, this on Google Classroom. And as we can see from the graph, please look at these graphs. You know, and I'm going through them kind of quick because there's so much information. Pause me. Look at what, you know, a grassland is, and I'll once again state it's kind of the same information that's in this one. This is just all the information together. So I do love this graphic, but if you want to look at specifics, this is kind of what meets a kind of tropical savanna grassland. You have these periods of sometimes it gets a lot of rain, but then most of the year kind of very, very dry. Temperature can kind of go up and down in regards to that as well, right? So do know that, you know, this, you know, that's tropical. I would say in regards to other grasslands, temperature doesn't mean as much. I would say this is more based on precipitation, gets these peaks and then a lot of dry periods. So it's not, you know, it's not a desert because deserts get very little rain all year round. These areas get a real high amount and then nothing for the rest of the year. And that's really what dictates a tropical savanna or grassland. All right, moving on. Here's another one. Here's another example. This is kind of the area I grew up in. This is really what it looked like. You could just see for days and days and days. And, you know, parts of Thailand are starting to look like this just because not naturally. It's because we're just chopping everything down. They're starting to look like this. But this is what I grew up with, and it's kind of a natural environment. But as you can see, we kind of have these peaks and then great dips, right? And also temperature as well as precipitation. So that kind of dictates those. Third big one we'll definitely talk about, characterized by low moisture levels, less than 30 centimeters per year, and precipitation that's very infrequent and unpredictable from year to year. Deserts have wide daily and seasonal temperature fluctuations. During the day, it gets very, very hot. Sometimes at night, it gets very, very cold. Now, I would say deserts, once again, this is more based on precipitation. You can have very cold environments that could technically be called deserts. We'll kind of call them tundras. But just know, deserts, you know, you often have this image in your head where there are these, you know, very cold, very hot, I should say, and no rain. I would say it's more based on areas with just less than 30 centimeters of rain per year. They can get really cold. They can get really hot as well. Okay. The type of plants in these type of environments exhibit water conservation characteristics such as water storing stems, thick epidermis to reduce water loss, and salt tolerance. So just plants that are really hardy, really able to collect water and hold on to water for a long time. So I used to live in Arizona, one of the biggest, you know, big U.S. desert, and there's called saguaro cactuses. They're super tall. They sometimes get 3 stories high. Insanely beautiful. But they have their root system can go on for meters, if not hundreds of meters. It's because they just reach out so far, their root systems, to collect as much water as they possibly can. So, you know, that's another adaptation. Just kind of throw ideas in there, what we'll be talking about later, of how they live in those environments. Deserts animals also have adaptations, right? Many are nocturnal and able to conserve water, right? They don't go out during day because that's when they can have more water loss due to the sun beating on them, right? Deserts are very vulnerable. Slow growing vegetation is damaged by off-road vehicles. It takes decades for desert soils to recover. Just know desert type of animals like tortoises, cactus, saguaros live hundreds of, you know, many years, if not hundreds of years, just because they're so ancient. I think actually the oldest type of living organism on land is I forget the name of the plant. It lives in Arizona as well. I'll remember it sometime. But just know that these are often plants because they just take so long to kind of get enough nutrients and water to grow, so they're often very long-lived. Overgrazing, livestock are destroying the plants of the southern Sahara. Without plants, the land cannot retain what little rainfall there is, and it becomes even more barren. So if you get rid of the small amount of plants that do exist, it has disastrous environmental implications. And then here's deserts kind of region. You can watch this video to kind of view deserts, but just know that the biggest thing here is the lack of very little water. Like I said, it can be very extreme temperatures to very low temperatures, but the big thing to focus on here is that amount of water, which is under 20 to 30, it's under 30 centimeters per year, is classified as a desert system. Deciduous forests, temperate regions supported by lush summer plants growth when water is plentiful. Deciduous trees lose their leaves in winter as an adaptation to freezing and temperatures. Think of kind of many parts of the United States has this. Think of those beautiful fall photos that you might have seen in some of the movies or in photos, right? When you see the bright yellows and oranges, that's a deciduous forest. Kind of the forests kind of go into kind of a hibernation type period during winter, and then they're bright green during the summer, and then they kind of die, not really die, but lose their leaves and go through the year. So obviously you're kind of already picturing what kind of temperatures and precipitation might be in this, right? We have a little bit colder temperatures during winter, a little bit warmer temperatures during summer, and more extreme type of kind of environment, right? But doesn't get too extreme, not like really, really hot like a desert region, or really, really a lot of rain like a tropical rainforest. It's kind of in the middle, but on the extreme of those, if that makes sense, right? But eastern half of the U.S. was covered with broadleaf deciduous forest when European settlers arrived, but much of that was harvested for timber. Areas in U.S. have regrown, although the dominant species are different now. Areas in Siberia severely threatened now as well. And then here you go. As we can see, gets a decent amount of rain, not nearly as much as tropical rainforests. Even though this graph makes it look like it is. Remember, tropical rainforests had near the 300, right? This is saying about the hundreds. And then also temperatures can kind of vary between 50, looks like it almost hits to be about what? Hits about, 30s, right? 20s and 30s, and then it can drop down below zero in some cases as well, and does. All right, moving along. Like I said, I'm sorry, guys. I don't mean to be rushing through these, but hopefully you kind of already have a background on these. You should, but I'm just kind of adding to it. Next one is boreal forest or kind of taiga. These are kind of the northernmost edge of boreal forest, but these are kind of species are more poor. It's a harsher climate, so this is kind of like deciduous forest, but you're getting into more of a now more of a wintry type of climate, right? Slightly more harsh, due to more cold and shorter summers. And due to this, it just limits the type of trees that grow and the growth rates. Mostly in these environments, you get kind of the pine tree look where the leaves, they doesn't have leaves that fall off and die. These are more kind of spiky type of plants, deciduous trees, right? A tree that is 4 inches, 10 centimeters in diameter may be over 200 years old. So once again, it's not getting a whole lot of sun, so these plants tend to be old as well in this environment. And then here you go, boreal forest. You can watch that, just kind of look at it. But here's a nice graphic. We can still obviously see a lot of trees, but they're getting less and less in number. And as you can see, the type of trees, they're more the pine type of trees or cypress type trees. And then here we can see kind of rain. Once again, not nearly as much rain as a rainforest, not even as much as a temperate forest, right? Because that was roughly 60 and 80. This is a little bit below it. But as we can see, extreme difference in temperature. It might not peak about 20, but then it goes all the way down to negative 30. So this is getting a bit colder in these environments. Next one, we're just going up kind of the latitude ladder, right? Now we're kind of hitting tundra, even more extreme cold environments. These are often treeless. Now, this is kind of what you think of as the Arctic or Antarctica, right? 2 to 3 months growing season, and even if it is growing season, it's usually mosses or like little shrubbery type things. And very harsh winters. Arctic tundra and alpine tundra. Arctic tundra just on the opposite sides of the planet, right? We have the north and south poles. Alpine is kind of on the very top of mountain, so think of the top of Mount Everest. This is kind of an alpine tundra. But once again, exhibits low productivity, but during midsummer supports migratory birds by the millions. So they kind of just come there and eat what there is there and then migrate out of there pretty quickly. For alpine tundras, occurring near mountaintops, but vegetation is similar to Arctic tundra, relatively low biodiversity, right? You don't have a whole lot of different biodiversity. I mean, think about it, right? Compare this to a tropical rainforest. A tropical rainforest, name 20 animals. I bet you it's super easy, right, to think of 20 animals that live in a tropical rainforest. Now think of 20 animals that live in a tundra. I bet you it's much more hard, right? Like polar bears, penguins, narwhals, right? Seals maybe, but very, very few come to mind, right? Because there is just less biodiversity in these areas because it definitely doesn't get the temperature. Temperatures are really, really low, right? So you don't get a whole lot of explosion of growth, not a whole lot of sunlight, and then just precipitation, it comes in the form of snow. So snow is not really, able to be absorbed by plants. It has to melt first. So very little rain, let's say, or precipitation that plants need. And this is kind of getting to be this is definitely a summer type picture. This is what a tundra might look during the summer, but as the winter, we can see it'd be packed full of ice and kind of glacier type areas. But looking at this, relatively very, very, very little precipitation because the precipitation that isn't snow, so it doesn't get rain that we need for plants, but also the temperatures just get so low and don't really peak. They just kind of slightly peak above freezing and then go back down for the rest of the year. So do watch that one. Okay, that's it. We're going to stop there. We're going to continue that on the next class. But guys, I hope I didn't rush through it too much, but it's already 26 minutes, so it's a little bit longer. I have to fly through it just because hopefully you've already talked about these in your past. This is kind of a catch-up, I guess, or to reclassify things. Do know, though, the most important one, we'll definitely be talking about rainforest because the biggest biological area. And we do talk about, the other ones, the main ones that we kind of discussed here, but rainforest is by far the biggest key one here when we kind of go on through this unit. Okay? All right, everybody, that is it. Please have a great day. Let me know if you need anything. Please take care.